What are op-amp common mode voltage range limitations? Imagine trying to listen to your favorite song on a radio that only works within a certain frequency. If the signal goes outside that range, the sound gets distorted or cuts out. The same idea applies to operational amplifiers when it comes to their input voltages. They have a specific range called the common mode voltage range, or CMVR for short. This range tells us the limits within which the op-amp can operate properly. If the input voltage goes beyond these limits, the device might not work as expected, causing errors or even damage. The common mode voltage is simply the average of the voltages at the two input pins of the op-amp, the inverting and the non-inverting inputs. The CMVR is specified relative to the power supply voltages, which are the positive and negative rails that power the device. For example, if an op-amp is powered from a plus 5 volts and a minus 5 volts supply, its common mode voltage range might be from about 0 volts to roughly 4 volts. That means the average voltage at the inputs should stay within this window to keep the op-amp functioning correctly. The reason for these limitations lies in the internal structure of the op-amp. Inside, there are tiny transistors that need a certain bias voltage to operate in their active region. If the input voltage approaches too close to the supply rails, these transistors can saturate or turn off completely. When that happens, the op-amp can no longer amplify signals linearly, leading to distortion or loss of gain. The exact limits depend on the internal design and the supply voltages used. Higher supply voltages usually mean a wider common mode voltage range. For example, an op-amp powered from plus 15 volts and minus 15 volts might have a CMVR of about plus 13 volts to minus 13 volts. But low-voltage op-amps, powered from just 3 or 5 volts, have more restricted CMVRs. This makes it essential to check the specifications when designing circuits, especially if your signals are close to the supply rails. The configuration of the circuit also matters. For instance, voltage follower circuits, which are used as buffers, are more sensitive to CMVR because the input voltage often spans the entire supply range. If the input voltage exceeds the CMVR, the output can saturate or become distorted, defeating the purpose of the buffer. To give a practical example, a typical CMVR might be from about 2 volts above the negative supply to 2 volts below the positive supply. So if your op-amp is powered from plus 5 volts and minus 5 volts, the input voltage should stay between about 2 volts and 3 volts to avoid issues. Going outside this range risks the input stage not working properly, which can cause the output to be inaccurate or the device to shut down. It's important to distinguish the common mode voltage range from the output voltage swing. The CMVR relates to the input stage, while the output voltage swing tells us how close the output can get to the supply rails. Both are limited, but they serve different purposes. Comparators, for example, often have wider input voltage ranges because they don't use negative feedback like op-amps do. In the end, understanding the common mode voltage range helps you choose the right op-amp for your project. It ensures your signals stay within the limits needed for proper operation, avoiding distortion or malfunction. When designing circuits, always check the CMVR specifications and plan your input signals accordingly. This way, your analog electronics will perform reliably and accurately, keeping your projects running smoothly.